Welcome to this lesson, lesson number 3, that deals with blockchain structure and types. Again, we are learning about Solidity Programming and also Introduction to Blockchain. This is a presentation of Coding Bootcamps. Blockchain structure and blockchain types. And we have covered this previously. And we've also covered the prerequisites. And just to recap, we did discuss ledgers in our previous lesson, ledgers in general, and the impact that they've had on society and the way that they have helped advance technology. So in a blockchain, blockchains track data, and the immutability is supported primarily by hashes. A hash is a digest of data. Any data value stored in an alphanumeric string can be hashed. There are several hash algorithms. These are just some. MD5, SHA-1, SHA-256. Hashes are very sensitive to changes. The sensitivity to the change is the number one reason to use hashes in a blockchain. Because if we detect a change in the hash, we know that some data has changed in the blockchain. Therefore, we know that that node has problems or has been tampered with. Then we can take action to overwrite that bad node with the data from an unaffected node. So if we could see here, the data here, this what is blockchain can be hashed, and this is using the MD5 hash. This is its hash string. This string here, a million, it can be converted to a hash that looks like this. So these are all the same length, 32 characters. A 0 hashes to this length. And the beginning of the Gettysburg Address can also hash to a string that's 32 characters in length. And if I remove this period here at the end, this hash would actually change. So hashes are asymmetrical, so there is no inverse hash function. In other words, you can apply the hash formula on one input and return output, but there is no formula to reverse the hash. The only way to do it would be by brute force. We can take a look here how we actually use the hashes to create a chain of blocks. That's our blockchain. So the blocks are filled with transaction data. We can see here. Once the block is validated, everybody says the transactions are good. The block's data is hashed to a hash value. So we can see here, here's our data. Then we have a hash, and a proof of work is also added. Or we can take a look here at the in block 40, all of these transactions here. And then we have we come up with a hash for the block. There was a previous block 39, and that was its hash. So this hash now is used in the header as part of the header for the next block. And that's how they are chained together. If any of the data here in block 40 would change, then this hash would change. And then it would no longer be pointing to block 41. Here's a slightly simpler variation. So we can see in this case that there are lists of transactions in each block, and there's a block hash, or block signature sometimes it's called. This block 1, its signature is the header of block 2. So we can see that this data in here, the Bitcoin transactions, are hashed up to this, say this value. This is obviously fictitious. We can see here that if someone went in and changed this, now George, who previously had 100, now has 500, we would see that the hash here would change, and it would no longer be pointing to the block number 2. So then the miners on the network can take action to overwrite block 1 with the correct data. And like we introduced in our first lesson, blockchains have different types. So there are public blockchains. And some of the attributes and properties of a of a public blockchain are here. They have that distributed ledger. They're fully opened. They are permissionless, so everybody has the same permissions on the blockchain. They can manage any asset type. Well, certainly second generation blockchains can. Each node has full access to the ledger. They are immutable, and just because of what we just talked about here with the hashing in the chain. Public blockchains are anonymous. They're visible to all users. And consensus, just like we saw proof of work, is based on the community's vote. And they do manage smart contracts, at least second generation blockchains, like Ethereum do. However, for the enterprise, for private businesses, not all of these properties are necessarily desirable. So a business doesn't want fully open, for the most part. A business does not want permissionless. Each node has full access to the ledger. That may or may not be desirable for a business. Anonymity may not be desirable. Visible to all users may not be desirable. And consensus on the community may not be desirable. We can see here what would be desirable. So a distributed ledger for a private blockchain, still desirable. Data is only seen by those who need to see it. Well, that's certainly desirable. Permission roles, yes, for the enterprise. Can manage any type of asset or data, absolutely. The ledger is only available to those that need to see it, for the most part. Immutable, good. Known users, visibility based on roles, yes, for the enterprise. Fewer nodes and known users, and certainly smart contracts. There was almost like a hybrid called a permission blockchain that many of these items that are struck here are not desirable on a permission blockchain. So permission blockchains are very close to what private blockchains would be. So an example of a private blockchain would be a hyperledger fabric, or a hyperledger sawtooth. And an example of a permission blockchain would be Corda. And some popular public blockchains, Bitcoin, everyone's heard of that, and that is again a first generation blockchain. Ethereum, it is a blockchain application platform, or instead of an operating system, it is an operating network. Ethereum was founded by a group of Bitcoin developers who wanted more robust methods for creating blockchain applications. And here is the Ethereum community website. And some popular private blockchains, Hyperledger or Hyperledger Fabric, Hyperledger Sawtooth. Multi-chain is also a popular private blockchain, which is very robust in development, as is Hyperledger. Permission blockchains. Corda is considered a permissioned blockchain, although it can be installed and configured to operate privately. And Ripple is also a permission blockchain. Here are some features of, say, the top 5 blockchain platforms for enterprises here. We can see Ethereum, Hyperledger Fabric, Corda, Ripple, and Quorum. And you can see here different entries here. Cryptocurrency, Hyperledger has no cryptocurrency. Corda has no cryptocurrency. So you can take a look here at some interesting data. You can try some hashing functions as well. So you can certainly search and find applications online. Here's an example of one. And you can enter a string and hash it and see what that string hashes. So in this lesson, we talked about hashing functions. Hashes in the structure of blockchain, introduction to the different types of blockchains, and an introduction to some blockchain, different types of blockchain products, Ethereum, Hyperledger, Corda. So please review the assessment. And again, please look at your materials for additional resources and reading. Our next session, we are going to talk about blockchain operation and mining.